Today we're going to learn in 6.4 a couple of more, the last two points of concurrency, the centroid and the orthocenter. So the first one we're going to learn about is the centroid. Now how you find a centroid is you find the median of the triangle. So you take a segment from the vertex to the midpoint of the opposite side. So the first thing you're going to do is you're going to find each of your midpoints. Okay, so you're going to have to do that I taught you in the last unit. You find each of your midpoints. Then you connect the midpoint to the opposite vertex. Okay, there's no perpendicular lines, there's no bisected angles. It's just the midpoints connected to the vertices. So it does not cut these in half, is not necessarily perpendicular. So remember that. That's important about the centroid, which is right there. So the interesting thing about the centroid is that it cuts each line, each median, okay, into 2/3. So the longer segment is 2/3, and this would be 1/3. This is your 1/3, and this is your 2/3. So you have to look at it carefully to see which is which, okay? So that's what it does for the measurements. So let's use that. Okay, using the centroid of a circle. So in RST, point Q is the centroid. SQ is 8. They want you to find QW, and they want you to find SW. So what do I know? Well, I know that this is the longer segment. SQ is the longer segment. So SQ is probably 2/3 of SW. And that's how they build upon it. So they set that up, they show that equality, then they substitute the 8 for SQ and solve by multiplying each side by the reciprocal, like this. Not there. Okay, and so the 2 goes into 8 4 times, 12 equals SW. So now that you find SW, all you need to do is subtract SQ, and that will give you QW. So let's have you do one on your own. So point P is the centroid of LMN. Find PN and QP. So we're finding this one and this one, and they're giving us QN is 45. So look at your diagram, find which one do you think would be 2/3, and then set that up. So you can push pause and work this out, and then come back and see the correct answer. Okay? So we're going to go PN is 2/3 of QN. So PN is 2/3 of 45. So 3 goes into 45 15 times. PN equals 30. And now I can just subtract QN minus PN equals QP. So 45 minus 30 equals 15. And QP equals 15. Okay, this is what the centroid looks like, and you can see that this one's on the side, this one's outside again, this one's inside, and again the equilateral looks the same as always. Okay, before we find the orthocenter of a triangle, we have to find out the altitude. So the altitude of a triangle is the perpendicular segment from a vertex to the opposite side, or to the line that contains the opposite side. Remember, you can use any side of the triangle for the base. The height is the length of the altitude from the base. So now, here's how you find an altitude. So we have a triangle. You take your compass from a vertices and you mark the opposite side. This centers your vertice on the base, on the opposite base, okay? Then you would take these 2 points with your compass and make the arcs, okay? And you would use the compass on both sides with the same measure, and then that line should go straight through and give you your perpendicular bisector. All right, so now that we know how to make an altitude, and on this one over here, the scalene, you have to extend the base in order to do that. So you go like this, and then you would do the same thing, and it would give you this point out here. All right, so now that we have the altitude, the lines containing the altitudes of a triangle are concurrent. This point of concurrency is the orthocenter of the circle. So there is your orthocenter. And here's what they look like on different kinds of triangles. So it depends on the type of triangle. The acute is inside, the right is on the triangle. And because we know that with a right triangle, the altitudes can be the 2 sides or the perpendicular connector height of the base on the other side, the hypotenuse. And then the obtuse is outside. So that's when you'd have to extend your lines to get. We're not going to be constructing any of these, but I just wanted you to be informed. So this is in your book, and so you might want to use this one instead of the other one that I gave you, but this is also very helpful to show you what each one is. So this is what you have to find, and that gives you the point of concurrency, and then what is the information that it gives you, that each vertice is the same distance, and then that shows you. So this is a good one. It shows you how to find them a little bit more than the other one. So use either one, and that's all for today.